Good morning, children. In this session, we are going to see two more examples for naming the organic compound, followed by soap preparation as well as detergent preparation. These things we are going to discuss today. First, let me see the example. See, CH3, first example, CH3 bond CH2, bond CH2, bond OH. Okay, so we are going to name this compound. Okay, IUPAC name. First, what we have to do as per rule 1, what I told you, we have to identify the longest chain. Okay, longest chain. So here, this parent chain. Okay, for this compound, the parent chain contains. This is the parent chain. Longest chain is nothing but the parent chain. This parent chain contains 3 carbon atoms. 1, 2, 3. Okay, 3 carbon atoms. So what is the root word for 3? Prop. Okay, what is the root word for 3? If it is 3 carbon atoms, then we have to use the root word prop. P-R-O-P. That is the first step. Okay. Second step. Here, all the carbon atoms are connected by single bonds. Okay. So what suffix we have to use? We have to use the primary suffix A-N-E. If all the carbon atoms are connected by single bond, then we have to use the primary suffix A-N-E. Second step is over now. Okay. Now we have to see the compound. Here the compound is connected with one functional group. Okay. OH is nothing but the functional group. So OH group is called alcohol group. Already we saw, isn't it? OH group is called alcohol group. Right. So now we have the next step. We have to give the number. That number which is closest to the substituent or functional group. Here in this organic compound, functional group is present. So we have to give the number from left to right or right to left. Right to left. Why? Because a functional group is closest to here only. Okay. So we have to give the number from right to left. So see 1, 2, 3. Like this we have to give the number. These numbers are called locant numbers, isn't it? Here the functional group is present here. Functional group or substituent, we will give the number to that. Means number is closest to the substituent or functional group. So we have to start the number from here. 1, 2, 3. So locant number of OH group is 1. Okay, because this carbon atom is closest to the functional group. So the locant number is 1. So here we have to write the suffix, that is secondary suffix. Already primary suffix we have finished. Next we have to write the secondary suffix. So 1 dash OL, all. Okay. So primary suffix is 1 because this carbon atom is closest to the functional group. So the locant number is 1. Put 1 dash. And what is the secondary suffix? This is the alcohol group. So we have to write the suffix end of the name, all. OL, 1 OL. Okay. So what we have to write? First one, the root word is prop plus A. A is the primary suffix because all the carbon atoms are connected by single bond. Next we have to write the secondary suffix in the bracket, 1 dash all. Okay, now we have to connect all this. Propane 1 all. Here A and E only we have put, but here we didn't put the E. Why? Already I told you as per rule 5. If primary suffix as well as secondary suffix is present, in that case we have to remove E, the terminal E from the primary suffix. So this E has to be removed. That is why we put AN here. Okay. Propane dash 1 dash all. The name of this compound is propane dash 1 dash all. Okay, like this you have to give the name. Second example we can see CH3COOH. For this compound we are going to give the IUPAC name. Okay, CH3COOH. The parent chain consists of 2 carbon atoms. Okay, 1, 2. Parent chain consists ethers, ketones, aldehydes, alcohols, hydrocarbons, etc. First one, esters. In our daily life, we use many cooking oils, isn't it? So all cooking oils and lipids contain esters. Esters are nothing but chemical compound, okay, which are derived from acids, whereas lipids are compound obtained or composed with fats or oils. Lipids play a very important role in our life, okay. So all cooking oils and lipids contain esters. Second one, ethers. Ethers are used as an anesthetic agent in hospitals, okay, and also ethers are used for pain killer. It is also used as a pain killer in hospitals. Next, ketones. Ketones are generally used as solvents, okay. Ketones are generally used as solvent. Also, ketones are used for stain removing purpose. Got it? Right. Next one, aldehydes. Formaldehydes is generally used in hospitals as well as in industries for anesthetic purpose, okay. So this aldehydes is also used as an anesthetic purpose or disinfectant, okay. So also aldehydes are raw materials used for various synthetic materials in industries. Got it? Right. Next one, alcohols, okay. Alcohols are used as solvent only, and also it is used as an antiseptic, okay. Alcohols are used as an antiseptic agents. It is also, alcohols are used as raw materials for various synthetic materials in industries. Got it? Right. Next one, hydrocarbons. Fuels like such as petrol, diesel and liquefied petroleum gas contains hydrocarbons, okay. And also these hydrocarbons are used as a raw material for various synthetic materials. So these are some of the organic compounds that we use in our day-to-day life. Got it, children? Right. Next we can move to soaps and detergents, okay. In our day-to-day life we use soaps and detergents. Soaps are used for washing purpose, cleaning purpose, bathing purpose and also for household purpose. Got it? Right. Soaps and detergents contains surfactants, okay. Surfactant means these are substances which tends to reduce the surface tension of liquid, okay. Both soaps and detergents have different chemical nature. Soaps are cleaning agents that are composed of one or more salts of fatty acids, whereas detergents are compounds or mixture of compounds, okay. Detergents are compounds or mixture of compounds. So first let me discuss about soap. Soaps are water soluble sodium salts or potassium salts of long chain carboxylic acid, that is called fatty acids, okay. Soap requires generally two main raw materials. One is fat and another one is alkali. The alkali which is used for the preparation of soap is, one is sodium hydroxide, that is called caustic soda, and another one is potassium hydroxide, that is called caustic potash. These two raw materials are required for the preparation of soap, okay. Soap consists, there are two types of soaps. caustic soda are called hot soap. Hot soaps are generally used for washing purpose. Okay. What is meant by saponification? Saponification is a process that involves the conversion of fats, oils or lipids into soap. Okay, into soap in the presence of heat by the presence of alkali in the presence of heat. Okay, I told you once again, I'll tell you once again. Saponification is a process that involves the conversion of fats, oils, lipids into soap by the action of heat in the presence of alkali. Got it, children? Right. Next we can move to soft soap. Soaps which are prepared by the saponification of fats or oils with potassium hydroxide or caustic potash or potassium hydroxide, both are same only. Okay, soaps which are prepared by the saponification of fats or oils with potassium hydroxide are called soft soap. This kind of soft soaps are generally used for cleansing the body, cleansing our body. This soft soap is generally used for cleansing purpose, cleansing the body, and also is generally used for washing purpose only. Got it, children? Right. Next we can move to manufacture of soap. Okay, soap manufacturing. Kettle process. Soap is manufactured by kettle process. This kettle process is the oldest process, but still now this method only used for manufacturing the soap. Okay, two steps involved for this manufacturing process of soap. One is the saponification of oil and another one is the salting out of soap. First, let me discuss about the saponification of oil. The oil which has to be taken in a large iron tank. Okay, the oil which has to be used for this purpose is taken in a large iron tank. This iron tank is nothing but kettle. Okay. Next step is 10% alkaline solution is added to this mixture. Okay, 10% alkaline solution is added to this mixture. The third step is the mixture is boiled by passing steam through it. Okay, the mixture is boiled by passing steam through it. Okay. After several hours, the oil which we are using gets breakdown into compound, okay, by the chemical reaction with water. This process is called a saponification process. Got it, children? Right. Next one is salting out of soap. The second salting out of soap. Next we have to use common salt into the boiling mixture. Common salt is nothing but ordinary table salt that we use in our day-to-day life. Okay. Common salt is added into the boiling mixture. Okay. Then what happens here? After adding the common salt, the soap is precipitated in the tank. Okay. The soap is precipitated in the tank, and after many hours, the soap rises at the top. The soap rises at the top and just looks like a curdy mass. Curdy mass means the milk that has to be curdled. Okay, curdy mass. Now the soap is taken and it allowed them to cool. This is the salting out process. This is the manufacturing process of soap. Two steps are followed. One is the saponification process and another one is the salting out process. Got it, children? Clear? Shall we move to the next one? Good. Next we can move to detergents. Detergents are salts of sulfonic acid. What I told you for soaps are salts of fatty acid. Right. Next we can move to the preparation of detergents. Detergent is prepared by adding sulfuric acid into the hydrocarbon obtained from petroleum. Okay. Then alkali is added to the boiling mixture in which the surfactant molecules, okay, in which the surfactant molecules, it do not allow to attract the minerals which is present in the hot water. That is why detergents do not form precipitates. It prevents the formation of precipitate even though calcium and magnesium salts present in hot water. Got it? Right. So next one, nowadays many ingredients are generally added in detergents. Okay. So what are the main ingredients they are adding? What is the use of that ingredients? Let me see now. First one, sodium silicate. In some detergents, sodium silicate compound is added. Okay, sodium silicate compound is added in some detergents to prevent the corrosion. And also it does not damage the washing machine. For that purpose, sodium silicate is added. Okay, sodium silicate is added to prevent corrosion and also it does not damage the washing machine. For that purpose, for some detergents, sodium silicate is added. Second one, fluorescent whitening agents. In some detergents, fluorescent whitening agents are added to give a glow to the clothes. Glow means shiny nature to the clothes. Okay, so fluorescent whitening agents are used to give glow to the clothes. Next one, oxygen bleachers. Oxygen bleachers, for example, sodium perborate is generally used to remove the stain from the clothes. For that purpose, oxygen bleachers are used. Example, sodium perborate. Okay. Next one, sodium sulfate. This sodium sulfate compound is used in some detergent powder to prevent the caking of detergent powder. Caking means due to moisture, the detergent powder it gets somewhat solid in nature, isn't it? Lumps, just looks like lump. In order to prevent that lumps, sodium sulfate powder is added. Okay, sodium sulfate is mainly added in detergent powder to prevent the caking of the detergent powder. Okay, in order to avoid the lumps. Next one, enzymes. Enzymes are used in some detergent powders. Okay, to prevent to break some microorganisms, that is microbiological substances caused by some stains. That is, enzymes are generally used in some detergent powders to break the stains which is caused by biological substances such as blood as well as vegetable juice, etc. So in order to prevent that, some enzymes are used in the detergent powder. Got it? Right. Apart from this, some chemicals are also used, okay, to give a pleasant smell to the clothes after washing with the detergent powder. Okay, so these modern ingredients are nowadays modern ingredients are added in the detergent powder to give to give glow for the clothes, to avoid from moisture, to give a glow, okay, to remove the stain like blood stain like that. That's why some modern ingredients are added. This way you can get one more question. Okay, so you should learn all these modern ingredients. What are the modern ingredients that we use, that they are in industry, in industries they are using many ingredients. No. So what are the ingredients? What is the main use of that ingredient? That also you should learn, children. Got it? differently with each other. Okay. It has, that is, a soap molecule has one polar end having short head, okay, and it is made up of carboxylate group, and it has one non-polar end having long tail, okay, having long tail, and it is made of hydrocarbon chains. Got it? The polar end is hydrophilic in nature. What is the meaning for hydrophilic? Hydrophilic means water loving. This end is attracted towards the water. Okay. And the non-polar end is hydrophobic in nature. Hydrophobic means water hating. This end attracted towards all the dirty substances and any oil stains on the cloth, but it is not attracted towards water. Got it? Right. So, a soap or detergent, when it is dissolved in water, you know very well the water contains molecules, isn't it? So, the molecules which is present in the detergents as well as soaps held together to form clusters. Okay. So these are called micelles. These clusters are called micelles. Clusters means held together or bunch. Got it? These micelles have long hydrocarbon chains, so it attracted all the dirty substances or oil into it. Got it? Now, the carboxylate end, it makes the micelles soluble in water. In this way, the dirt is removed or washed away with the soap. This is the cleansing action. Got it, children? Right. So next we can move to advantages of detergents over soaps. What are the advantages? First one, detergents can be used in hot water as well as in soft water. Got it? Next one, detergents can be used in acidic water as well as in saline water. Saline water means salt water. Okay. Next, detergents can be used in cold water and we can easily rinse with hot water. Detergents have long hydrocarbon chains, so it easily gets degraded. It's a biodegradable. Okay. Detergents can be used for washing woolen garments, but you cannot use soap for using woolen garments, right? And detergents are used for removing the water grease stains and all. Also, detergents makes the garments, okay, makes the synthetic garments brighter as well as whiter. Got it? So these are some of the advantages of detergents over soaps. So next one, biodegradable and non-biodegradable detergents. What is biodegradable detergents? Here, these detergents have straight hydrocarbon chains, so it easily degraded by bacteria. Whereas if you take non-biodegradable detergents, these detergents have branched hydrocarbon chains, so it is not degraded by bacteria. That's the difference between biodegradable and non-biodegradable detergent. Biodegradable detergents means these detergents having straight hydrocarbon chains, so easily gets degraded. But non-biodegradable detergents are branched like this, okay. So it will not get degraded by bacteria. Next one, what are the disadvantages of detergents? Generally, detergents have two disadvantages. One is, detergents are highly expensive when compared to soap. Next one, as I told you, detergents have branched hydrocarbon chains, so it is not degraded by bacteria which is present in the water, hence it causes water pollution. These are the disadvantages of detergents. Got it? Next one is TFM. You might have noticed in soaps TFM. TFM means total fatty matter. Okay, total fatty matter. This TFM actually it mentions the quality of the soap. If the total fatty matter is higher, then we can assume that it is a good bathing soap. Got it? Right. So next we can move to the comparison between soaps and detergents. Already we have discussed separately soaps and detergents. Now we are going to compare it. Okay. First one, soap. Soaps are made of sodium salts of long chain fatty acids, isn't it? Soaps are made of sodium salt or even potassium salt of long chain fatty acids, whereas detergents are made of sodium salts of sulfonic acids. Okay. So next point is soaps. The ionic part of the soap is COO minus Na plus. Okay. The ionic part of soap is COO minus Na plus, whereas the ionic part of the detergent is SO3 minus Na plus. The ionic part of the detergent is SO3 minus Na plus. Next one, soaps are prepared from animal fats or vegetable oils. Okay, soaps are prepared from animal fats or vegetable oils, whereas detergents are prepared from hydrocarbons obtained from crude oil, that is petroleum. Okay, so detergents are prepared from hydrocarbons obtained from crude oil. Next one, the effectiveness of soap is reduced when used in hard water. Why? Because in hard water calcium and magnesium salts are present. Hence its effectiveness is reduced when you use the soap in hard water. At the same time, in detergents, it is effective even in hard water. Okay, even though in the hard water calcium and magnesium salts are present, this detergent it prevents the formation of the precipitate. Okay, so next one, soap forms scum in hot water. Scum means dirty layer. Soap forms scum in hot water, but in detergent does not form scum in hot water. Okay, so next one, soap has poor foaming capacity, but for detergents it is not like that. It has rich foaming capacity. Okay, for soaps it has poor foaming capacity, whereas for detergents it has rich foaming capacity. And the last one is soap is biodegradable, whereas some detergents are non-biodegradable. That is branched type of detergents are non-biodegradable. Okay, it's an important 5-mark question. All the points you have to learn, children. What are the contents we discussed in carbon and its compounds lesson? Everything you have to go through it, children. Thank you.